Fusion is the process that powers stars. The intense gravitational fields at the centres of stars enable fusion to occur, assisted by quantum tunnelling effects, and we observe the energy released as light. The Sun's core has a temperature of 15 million degrees Celsius, and this intense energy rips electrons from their nuclei, forming a charged gas called a plasma. The process of fusion relies on these nuclei getting close enough to each other such that the attractive strong nuclear force overrides the electrostatic repulsion between the positively charged nuclei. When this happens, the two nuclei fuse to become one heavier nucleus, a process that releases a lot of energy. This energy is equivalent to the difference between the binding energies of the original nuclei and the resultant nuclei. The binding energy is the energy required to break a nucleus into its constituent parts. Fusion releases the most energy when very light nuclei are fused, but it can form up to nuclei of iron, atomic number 26 on the periodic table, within stars. Heavier elements are only able to be fused during massive supernovae events when energies are much higher than even stars. There are three main fusion reactions that occur in stars. The first is between two hydrogen nuclei, or protons, one of which converts into a neutron via beta decay, and a deuterium nucleus is formed. The second is between a proton and a deuterium nucleus to form a light isotope of helium, and the third reaction involves two light helium isotopes fusing to create a helium and two free protons. Isotopes are nuclei of a certain element with a different number of neutrons than usual. For example, deuterium is a heavy isotope of hydrogen, as it has one more neutron than a typical hydrogen nucleus, which has none.